Welcome back, everybody. Thanks for joining me around the virtual telescope this Monday morning. Hope you had a wonderful weekend. Mine was very busy, but very productive. So anyway, welcome to a new month, the month of March, as we enter galaxy season here in northern Utah. The weather today, we have a storm coming in, and I'm hoping it clears out enough by 4 a.m. tomorrow morning so we can see the lunar eclipse. Just fingers crossed. The forecast isn't looking so good for us. Hope it's looking better for where you're at, if you're in the zone where you're able to see the lunar eclipse tonight. Anyway, wonderful article came out. It's on Supernova, of course. I love stellar stories about stellar birth, death, and the life and death of stars, so to speak. This one's called The Ghost in the Machine. The James Webb Space Telescope finds its first supernova progenitor by looking back on supernova 2025 PHT. Here's an image from the James Webb archives. You can see in a little red box there, I have highlighted where supernova 2025 PHT happened. It happened in the galaxy in NGC 1637, which is in the constellation of Eridanus. And for those of us who love to spend our nights on finding various objects and observing them in the night sky, there's a certain thrill when something new appears. On June 29, 2025, the All-Sky Automated Survey for Supernova, ASAS-SN, caught a brilliant flash in the spiral galaxy NGC 1637, as I mentioned in Eridanus. Designated 2025 PHT, this supernova quickly became a must-see for professional assets. It was really too faint for amateurs, but professionals jumped on it, like they usually do. While most eyes were looking at the explosion itself, a team led by Charlie Kilpatrick did something every savvy observer kind of does. They checked the archives. They went back. If you know anything about supernova hunting, like I will set up my C-star, and I have certain galaxies that I actually try to image 2 or 3 times a week now, and I'm just looking for any changes in the galaxy point of light that wasn't there before that could be a potential supernova. Then you can actually report it, and you can actually get credit for finding a supernova. And there's lots of people who do that. Anyway, and to do that, just as an amateur, you're always looking back and comparing an image from tonight to past images to see if that supernova actually has appeared. So, in what marks the first ever detection of a supernova progenitor by the James Webb Space Telescope, the team managed to look back at data Webb had captured in 2024, just months before this star exploded and went boom. What they found might finally solve the case of missing red supergiants. Why are they missing? Well, we've known for a long time that the most massive stars should end their lives as bright red supergiants. Logically, we should see these luminous giants in pre-explosion photos of nearby galaxies, yet they've been strangely absent from our surveys. Webb's look at 2025 PHT provides the smoking gun. It turns out these stars aren't missing, they're just hiding behind a very thick veil of their own making. This progenitor was the reddest, dustiest supergiant we've ever seen explode. It was so shrouded in dust that Hubble couldn't even see it in the visible spectrum. Webb's infrared eyes, however, pierced right through that shroud to find the star before its final act. You can see that in these images. Again, here's James Webb, and there's the supernova. Before the explosion, very bright red supergiant here in the top image here. Then you can see Hubble in August 2024. The star basically has disappeared. It's not even being able to be seen. It's just an undetectable visual. But Webb in October 2024 pierced right through it. It was still there. And then you could, of course, Hubble in July 2025, when it went supernova, was able to capture it. So, carbon burps and cosmic recycling. The real surprise came from Webb's MIRI and NIRCam data regarding the composition of that dust. Usually we expect silicate-rich dust from these type of stars. Instead, 2025 PHT was surrounded by carbon-rich material. It looks like these stars was burping out carbon from its interior shortly before the end. A final violent exhaling of the elements it spent millions of years forging within itself. So what's next for the amateur perspective? Well, I actually sketched and observed NGC 1637 back in December of 2017. I have it over my blog. There's a link here. Here's the sketch. What I wrote back then was it's a face-on spiral galaxy in redness. I used a 22 millimeter T4 Nagler with a 7 millimeter Pentax XW, a 12 millimeter Delios type eyepiece, along with a Type 2 paracore. It's a very large and very bright spiral. The 22 T4 Nagler easily detected the galaxy in its field of view. The edges and extremities faded into the sky background nicely. It was elongated north-northeast to south-southwest. The high magnification used shows a mottled core with bright extension, and arms were evident, which I tried to capture in the sketch. Discoveries like this change how we think about every red giant we can see. The upcoming Nancy Grace Roman Space Telescope is expected to find even more of these pre-supernova stars, catching them in the middle of their final dust burps. It's a reminder that the lights on a dome we see at night are dynamic, living, and dying engines. Next time you're out under the stars, look at those red giants and wonder which one is currently wrapping itself in a carbon shroud, preparing for its final brilliant bow. Clear skies. Hope you found that interesting. Link to the article there. It's well worth your time to read it. Thanks for joining me. We'll be up next with another one in a minute. Have a great one.